this webinar today. I'm sharing this with Rupali, who will be leading off. Before we start the presentation, I just want to advise everybody, all of the attendees are muted, and this is to prevent feedback and unnecessary office noise from the different locations. And also at the end of the presentation, you'll get a screen that comes up with a brief questionnaire. And I've said this, I know we have a lot of repeat people here. Please take just an extra minute, if nothing else, to nail me to the wall, because I love it. So do take that extra second. It'll only benefit our presentations to you and hopefully present more of what you're looking for in the future. So with that, I'm going to go ahead and turn it over to Rupali.
Thank you, Dick. So the topic for today is surveillance, IP surveillance growth, and how do we define it? How do we measure ROI with the IP surveillance growth that we see today? But there is a lot of talk going on for defining value, ROI, saving from IP surveillance systems. The question is, can you measure ROI? What systems are there that can return money to their investors? Are there really any such systems out there? Now, what one means here is getting value in terms of savings, which is associated with these systems. The matrix of the system, the ROI, would depend, I think, on product, application, and project specifically, on who will be using the system and what will the system actually accomplish. So the question pops up again. Is there any matrix or measurement of determining ROI on the IP system? Well, I would say there is no set way of knowing that. However, depending on your project, the questions that will lead you to saving money with IP surveillance system are to know if the product fits the application, if the product is compatible with the rest of the equipment, and if the product is simple to install, program, and use. What type of warranty and support does it come with? If it's like a 9-to-5 on-site support, or if it's a 24/7 support, if it's a robust system that will last for years. One of the key approaches that helps is to categorize requirement into a chart of must-have and like-to-have features that we will discuss later in this presentation. This chart here looks different for each product, benefit categories. Its purpose is to match benefits and requirements to cost. Benefit categories like a safety cost reduction, business cost reduction, security cost reduction. These are the savings which are associated with benefits derived. When you are talking benefits, for example, in terms of camera, its features embedded in the IP camera processor like motion detection, region of interest, cropping and masking, network auto discovery, analytics. These are all examples of such benefiting features. One more example of this is the email notification that cameras send, for example, for an IT room to its IT people. Now we are assuming this is a shared space, a multi-purpose space here. So these notifications which are sent to the IT people, it helps them to keep an eye, keep track of who is coming in and out of the room. In many such projects, there is no need to record videos. The cameras are just made to take snapshot email and send to the selected IT people. Here they do not have the occasion of using recording, mostly for anything. Now, I would say that this is high ROI. This is where you get saving. Having reliable analytic motion detection. So events like opening the door, turning lights on, detects the motion and takes a snapshot. So when camera saves time for safety investigations, that will be safety cost reduction, I would say. The other good example to cite will be IP storage. The traditional DVRs that are pre-built and tested right out of the box units, they function with very little interaction from the users. However, there are also potential drawbacks to be considered with a standalone DVR model, such as expandability or upgrade. Now, if there is a need to expand the surveillance system to accommodate, for example, additional camera beyond what it can currently handle, most likely a new unit needs to be purchased in such situation. Some hybrid DVRs, though it can handle IP cameras, yet they have limitation of scalability. NVRs are scalable and they can give optimal performance too. So depending on the project, like I said before, the total cost of ownership of complete system should be taken into account. Here we can also compare the cabling of IP system as against the analog system. Cabling is 3 times more expensive in analog than in IP system. This is because separate power cables have to be used with analog, whereas in IP system we use Power over Ethernet, PoE. So it is necessary to include the cost of labor, as it is a significant cost of the total job that is done in a project. So mostly the larger the system, the more favorable cost of IP-based system, I would say. So when you're doing your calculation, it is very important you take into account the totality of all costs incurred today and in the future. This will actually determine your value and savings from the system. I would now like to give over to Dick, my co-presenter, who would be taking this presentation forward.
Looks like my screen is up. First, I just want to let you know this is this section. We had an employee emergency, so I stepped in, and I'm going to take a previous presentation and try to bend it into a little bit more about on top of return on investment and so forth. So, if some of it looks familiar, it is. If you still have technical questions, please throw them out. If you have questions regarding ROI, initial investment, and contribution to the solution at a financial level, please run them by me. Okay, basically, excuse me. We're gonna start a little bit before the products that we actually sell. Part of the planning, uninterruptible power. We have the numbers, they're up here. Average business loses power 8 times a year, okay, for about 27 minutes. So the question is, right off the bat, what are your people going to be doing when your surveillance system is down? How much is that costing you just at manpower levels? What are the penalties that you can incur for lack of coverage during these periods? What are the legal issues with regard to a video that you're supposed to be presenting? The single most likely area of downtime is going to be power. Protect yourself. Short term, UPSs are a great idea. They work fine. However, if you're forced by contract for longer term coverages, do consider smaller MG sets for your central site, and upscale your UPS battery backup times at your remote fringe sites. The other thing that normally happens and people don't think about it is inadequate cooling. They started out with a surveillance system that was relatively simple and small. There were no cooling issues. The office was able to take care of this. That's not the case when you start to scale things up. At a central site level, make sure when you're planning, you accommodate the new products. People now have 384 terabytes of data. That's an entire rack of thousands of watts of power being displaced into the room. Cover yourself. Also consider areas where items are being stuck up in ceilings, switches, power supplies. These areas are always inadequately cooled. So when you're snicking things here and there, it's very easy to work. There's generally a facility HVAC person. He can divert cooling to that area. Keep things cool. Keep them within the office specifications of the product. Next, noise. Make sure, this goes to overall reliability of a subsystem. Make sure that your cables are routed away from high noise items, transformers, those types of things. Make sure that all of your cables are correctly installed. If you don't terminate your cables correctly with grounds on both sides, you're going to act like a big antenna. And believe me, finding these problems is very difficult. So look for those in the very beginning. Make sure the specs are very clearly covered. Okay.
Nick, I got a question.
Shore up those, yes, yeah.
It's back a slide or two now to UPS. How long should battery backups last?
You know, that's almost on a case-by-case basis. The first thing I would do is all power companies are required by federal law to maintain records. At a minimum, it's a quick call. You might bounce around within their facility a little bit. It's a quick call to find out, even in your specific locale within their power grid, they can tell you what the average power outage is and how many times a year. So at a minimum, plan for that. And then within that specification, you have to balance, again, we're talking about initial investments, cost versus likelihood of failure, and the backside costs of not being able to perform the tasks of surveillance and intrusion.
Great, thank you.
Okay, shore up those network connections. There are pieces of the puzzle that are always going to be single points of failure. Again, we're going back to when we're stressing here money on the front side or resellers presenting to end users. Consider the additional expense versus the exposure, right? On the left-hand side in gray and blue, I have a single switch, a single NVR, another single switch. Any one of those items goes down, you're down. The cheapest thing to do is trunk your ports, double them up. Ports on switches are cheap, cables are cheap, right? So you've increased your availability. If one of those trunks or switch ports goes bad, it'll automatically fail over to the other port. We're not talking performance, we're talking strictly exposure for downtime. The next step up, add a switch. They can run in parallel. If one fails, it'll auto path over to the alternate route. Okay. Here's a quick show. You guys are probably very familiar with this already. Two different video feeds, two different routes for them to go, optimal performance. Okay. I lose any of these items in that left-hand string, links, other than hardcore storage and CPUs, you'll continue to run. It'll be seamless. No one will know it'll happen, and you'll be afforded a non-rush opportunity to fix your switches. That's another area that you have to contemplate on when you're considering your investment. You know, it's one thing to have a 9x5 contract, 24x7x4 contracts, cost a fortune. So again, there's cost savings in the event of failure that can be applied towards initial planning. Okay. I'm going to touch on storage. These are all storage musts today. We're not talking about IP SAN. We're not talking about high availability SAN at this point. We're talking all storage, no matter what you have running there. One, redundant hot swap power supplies, redundant cooling to the disks, RAID protection. How far do you want to go? RAID 5 provides you with one drive failure per array. RAID 6 provides 2 drive failure. Balancing these items. These are pretty standard features. However, you find when you're looking and you're cutting corners or you're asking people to drive price down, they're going to drop that hot swap power supply. They're going to drop their subsystem didn't come with redundant cooling or notification. So what will happen is you'll drop into a less expensive product. Balance the cost of an extra drive per array. RAID 6 protection is going to cost you $200 just to cover your data in the event of a 2-drive failure. Make sure that you have notification capabilities in place. If product's going down and you don't know it, that extends your outage time and your liability and your risks. Bottom line, poor cooling contributes to 90% of premature electronic and electromechanical failures. Power supplies, you got a 75% chance of one of those, a power supply failing within a 2-year period. Arrays with 16 drives over a 2-year period, you're going to have at least one drive fail. Balance a $400 investment for an extra drive in a RAID 6 configuration against losing all of your data. And that's what happens if you lose more than one data in a RAID 5 configuration. What's the cost to restore that data? Did you have a good backup plan in place? We don't see a lot of good backup planning in place. And what you guys are relying on is the inherent reliability of the subsystems.
Dick, I have a question for you.
Yes.
When should RAID 6 be used over RAID 5?
You know what, I run that on configuration and capacity more than anything else. Unfortunately, there are a lot of configurations, a 16 terabyte requirement or 15 terabyte, very common. So with today's boxes, they're typically 3U and 16 drives. When you're driving up towards an edge of 15 terabytes and you say, and I want RAID 6, well, you're forced to drop down to, say, 14 terabytes of usable capacity or add another box. You're left at that point with that same decision that you're going to find in each of the levels. Camera planning, everything involved within creating a correct surveillance environment. Is it worth the extra $3,000 so that I have RAID 6 provisioning versus RAID 5? That's a tough one to call. If you're sitting there with 8 terabytes and your box can expand, then RAID 6 is inexpensive. It's just a disk. One disk's cost. So explore the opportunity when you're on those just flipping over and adding an enclosure. Ask the question, can I upgrade to a higher density drive and have more room in the box? How much will that cost? You'll find that maybe going to a higher density a drive or a slightly larger box will cost you $1,000. I'm just throwing out a number versus not being able to provide RAID 6 protection. It comes down to cost and negotiations and understanding between the planners and the people that are going to end up with the solution.
Great, thank you.
Okay. I want to point out again, and mentioned this earlier, anytime you have a one of, you have a risk. In this particular case, I'm pointing out NVRs and single controller IP SAN storage. If you have a group of cameras and you have 50 cameras and it's in a remote fringe and it has a single NVR, you have to, again, weigh what is the value that's being placed against having all 50 of these cameras work all the time. Is it an absolute must? If it is, you're going to have to consider higher availability solutions for any of your NVRs that are a single point of failure. If you have 50 cameras coming in a fringe and you have 100 cameras coming across 2 single NVRs in a central site, how much is it worth to maintain uptime? And then explore the cost of a higher availability NVR. It's funny, the market has really grown just in the last 2 years. When I first came on board, the beginning buzz was high availability storage. I have to have the storage. It has to be high availability. I have to be able to read and write from it. And we designed the architecture, and I was always saying, what about the NVRs if any one of those go? And they'd say, well, we don't have a solution. today there are solutions, and there's a number of different ways that you can effect high availability. We've touched on switches. We can do it at an NVR level, and a little later on I'll show you a high availability storage and how it also lies in the topology. Okay, we're going to be more product specific than generic in this this presentation. High availability IP SAN storage. This is a typical simple drawing. We can always expand this with more cameras, more PoE switches, multiple NVRs to support higher camera counts. But the basic architecture is this layout. And within a high availability situation, we're specifically with regard to IP SAN storage, you have to have the ability to lose a NIC in an NVR. You have to cover yourself with switches on the IP SAN side. This is completely separate from the camera SAN side or LAN side. You have to, any of the components within your unit. So when you're shopping, you're looking, you're presenting, ask these questions. Can I lose a NIC? What'll happen? If I lose the switch, what's going to happen? What happens if I lose one controller and it's a single controller IP SAN storage product? If it's a single NVR and the data is held internally, what happens if I lose that RAID controller? You're down. Do I have an option where my data is held internally within my NVR for a higher level of redundancy? No, you don't. That's how central storage came to be. Power supplies, drives, we touched on this. I showed 2 drives. That would be a RAID 6 failure. You could lose 2 drives and continue to work. Power, make sure that all of the components on the side, your IP SAN or your NVR portion of the subsystem, you have redundant power. Not just in the storage. Look for that feature in the switches. Look for that feature in your recorders. And last, can you lose a whole controller? We touched on that just a second ago. If your data is held internally and you were to lose a RAID controller, you've lost all of your data. Depending on how the failure goes, you could have lost all the data even when the RAID controller broke. Okay. Within R, what we define as high availability, all of these components could fail. Every single one of these items I have X'd out, and you'll continue to be able to write data and read video or look at video. 5 nines, that's what you want to ask. Do I have a virtually 100% assurance that my storage is intact? Okay. High availability NVRs. Talked earlier, you have one NVR for 50 cameras, NVR goes down, a single switch goes down, you go down. Depending on your application, if you require that NVR for viewing, you're blind if you cannot access the cameras directly. So what happens in this situation is you're going to have cameras, you're going to have, in this case, a single switch, and it's going to mirror its ports out to 2 separate NVRs. One NVR is active, the second one's running in a passive mode, waiting to take over. Then we are funneling out, and in this case, since we're talking about NVRs and not storage, I have a single controller product depicted. So I'm covered. I'm covered at an NVR level. My fail points are up in my camera LAN, and actually in this case down in my storage LAN. Single switch, single controller storage.
I have a question on this
yeah.
slide. How many licenses would you need?
You have to, first off, each of the NVRs, because they're running their own operating system, you'll need a operating system license in both of the NVRs. And it depends, and I'm not delving into quite the detail as a previous presentation. It depends on the application that you're running. If you're using a enterprise class surveillance software, they generally offer a feature for high availability. They're going to tag it as corporate or enterprise, and you would only need one license in that situation because they realize both machines are being covered. If you're using a virtual operating system, you will need a license for both a license package that will cover both machines, both of the NVRs, as well as the number of CPUs that are in each of the NVRs. So they different companies package differently, but basically they package by number of boxes and number of CPUs. So it's actually how implementation dependent on how many licenses you'll need.
Great, thank you.
This is just a diagram very quickly to show how high availability works using a virtual OS. I have a primary NVR on the left, a secondary NVR on the right, representing the physical contents or the steel enclosures. So you have a core level that now is your virtual level in your virtual OS. On top of that, you run your guest OS. It can be Linux, it can be Windows, whatever the operating system is that you need to run your application. Then later on top of that is the surveillance. So in this case, I'm talking about VMware. It could have just as easily been Citrix. Citrix is going to enable the operating systems and the applications. Citrix is going to handle the failover. Now, it's not transparent. It's going to take the amount of time that your surveillance application takes to come up. VMware's application aware, it's OS aware, it's failure aware. When the secondary NVR loses its heartbeat, it says, oh, I've got to take over, I've got to fire up the surveillance application. So there will be a small delay between, I've heard as low as 5 seconds, I've seen 15 seconds, I've heard as long as 2 minutes to bring up the application and have all of the camera's feeds start to feed through the box to your storage. Again, weighing, you've got double the hardware, you've got extra license costs, you've got extra NIC ports, you've got to accommodate extra server ports. What's the cost to implement versus the benefit that you're going to derive from it? The perfect no single point of failure surveillance system. We have spent as much money as we can spend and to make sure that we have 100% uptime. We'll call it 99.999% because everybody loves 5 dimes. Okay, dual feed cameras, or at least a camera doing a split out of a switch. Redundant camera switches. Redundant trunked lines between the switches to the NVRs. NVRs in HA configuration. Again, we're trunking the lines back out of that unit into the storage SAN. And we're feeding now with, again, redundant switches. We got redundant multiple paths crossing between the units. And our storage is covered by dual iSCSI controllers, dual array controllers, RAID 6 protection. Not mentioned, but also within the storage, the customary, and remember, all storage musts. Redundant hot swap power supplies, your choice of RAID 5 or RAID 6 protection, always. Don't go with the JBOD. Drive goes down, all your data is gone. But never remembered what happens if the central site goes down. How do I restore? If you have different levels, you might plan, for instance, for everything except for the hurricane that never hits Norfolk, Virginia. And lo and behold, a hurricane scoots up, goes right up the bay, and just knocks out Norfolk. All right, the site's flooded. It doesn't matter. All of the redundancy, all the UPS capabilities, all the money that you spent, the building is destroyed and you lost all the equipment. What's your requirement to maintain video no matter what? Plan for worst case disaster. You do not have to create an entire failover site unless your requirements dictate it. But at a minimum, consider storing your video data remotely. You can, the features built into our products to be able to talk across a lower speed link and mirror all of the data, specifically just the video is all that you have to do, to a remote site that would be high and dry and safe. Now, once your primary is restored, you can bring this back. Worst case disaster, not just natural, not just fires. Unfortunately, we've seen we have nuts. So I bring to mind a job I was working on, and was covering an airport and part of a harbor and the surrounding areas, and we'd covered everything except I said, what happens if you blow up the building? How are you going to know? Where's your video to show who did the blowing up? How did they do the blowing up? And immediately there were extra monies found to be able to accommodate a remote storage site just where the video is going to be mirrored to. So if something did happen and it was a terrorist threat, they can take this box, install it on another system, and view the video and see exactly what happened. Okay, that's basically all that I have right now. Do you have any extra questions about the technical architecture, hardware questions, and or even a balance of cost on the front side versus backside cost incurred without careful planning?
Yes, I do have one question, Dick. Actually, it's
Okay.
a two-part question. How large, regarding the Seahawk SX, how large can it grow, and are there any limitations?
Let me bring back a, let's see if I can draw something in here. The standard Voyager can grow to 512 drives. I'm sorry, 256 drives. That's that's a half a petabyte of storage. But what you can do, that you can take this product. Let me see if I can get this drawing right here. You're not limited in total capacity of a single unit. You can take this unit, create, and expand with multiples of these units as your camera load grows. So while you're limited in the single storage constraint to half a petabyte, the reality is when you add cameras, you're going to have enough ports, so you're going to add switches, you're going to add more NVRs, okay? And so while you're doing this, your cameras are more or less going to be multiples of subsystems. So you're just going to add another, couple of NVRs across here. You might have to add another switch, and then you're going to feed back in through the same network back down to this. So the reality is how they expand, how a surveillance system expands through the use of NVRs and cameras and switches, plays the same way into the virtual storage.
Okay, great. I had another question come up. Can I start small and add redundancy? Are the systems modular enough to handle that?
Yes, they are. A typical HA requirement is normally identified on the front side, but we are able to configure our Seahawk SX line with a single controller and plan to add in a second controller at a later date. The other thing that happens is typically when you add an HA later on, it seems to be driven more by capacity growth and fear of loss of data. So a lot of times what happens is people will start with our Seahawk S or L family, which is our single controller product, and when the HA and the capacity requirements are growing, if you will, the fear, they'll replace that ISC with or Seahawk, excuse me, single controller product with the high availability Seahawk SX, and they'll reprovision the old Seahawk L as a remote site or as a backup device and mirror to that product so that they're covering themselves in the event of some odd occurrence that the Seahawk SX wouldn't be available.
Thank you.
I think that's, if I don't have any more questions, key, and it kind of plays into Rupella's beginning speech, is plan for the worst case, balance the cost versus penalty. And high availability seems to now, since it's here, yes, it does cost more. I would say with regard to 32 camera opportunities higher, everybody is going HA. And we're hearing a lot more about the high availability of NVRs and extra protection measures that we can design in. So with that,
Dick, I had a question come in. Can I scale performance as I add redundancy, essentially kill two birds with one stone?
Yes. Well, actually what happens is within, it requires planning. When people talk about scaling performance, and I invite you, we talk about, we have some webinars that talk about performance tuning. Our products are designed not to be a single box. They're designed to expand vertically and then horizontally. So within the vertical constraints, you're going to expand a lot less expensively by virtue of our architecture. But what's most important, and this is key in any IPSAN implementation, maintain multiple iSCSI volumes so that you can run volumes across multiple pipes. You can balance them across multiple NVRs, multiple iSCSI controllers. So when you're expanding, our product doesn't take a performance hit, obviously, until you get to the end of the rope where you can't expand anymore. That's the maximum you can. But our products are all designed to expand, and since they're not taking a performance penalty as they're expanding, in essence, you are increasing the performance and the capability of the subsystem. When performance is a must, and to be perfectly honest, within the general video archiving or storage environment, they're not high performance, more bandwidth cognitive, and more can the NVR process the data. Yeah, as you expand, they do get more power within the constraints of that single storage stack.
Okay. Dick, can you talk about our Lifeline products, the Flashback and RMS, for a moment?
No, I can't. What are the two products?
Lifeline products, the Flashback and RMS.
No, I can't. I don't know anything about those. I'm sorry. But I can find out.
Okay.
I can find out, and if you can give.
Yeah. Hang on. I think I'll be able to bring in additional resources on that. Hold on just a moment. Okay, I'm bringing in additional resources, so bear with me for just a moment.
Okay, hello. There are two